There we go. So, hi everybody. I'm excited to just hang out, spend some time with you. Um, prime numbers. I don't know if anybody else needs a discussion on that. Prime means it's the stuff doesn't divide it. So two is prime. Good. Divisors of prime two, one and two. Three, nothing goes into three. Four, well, four is two times two. Five, prime. Six, not prime. Three and two. Seven, prime. Eight, two times two times two. Nine, three times three. 10, two times five. 11, prime, right? And so the concept is you can just ask the question, does anything divide it? And so this is for exam 3. And I'm just going to go ahead and get my screen shared here. I'm scared. Okay, share the screen again. Screen 4, yes, 4, good. Okay, so hopefully you see this. Drag this over here. Let's just read this. So I'm gonna grab that and I'm gonna drop this in here. Paste it in. Okay, estimating the number of primes less than x. Write a program. Yeah. How many primes are less than, and let's wrap it there. Fit a curve to your estimate. Positive integer. Cool. All right, let's keep it rocking, friends. So, 4 int, and then I'm going to say check equals 2, check less than range, check plus plus. We're going to drop some curly brackets, right? Now, let's do int range 10. Cool. Now, print, too many languages. Cool. Okay. How many primes are less than? So it should be less than. So we should check. So we should say if is prime, check, and we'll say, and we'll do curly bracket. Okay, if is prime. So if that's true, sy out, say check is prime, and then we'll do int number of primes equals 0. Why did you beep at me, phone? Oh, good. It's Domino's Pizza letting me know that I can still get pizza from them if they like. Okay, so we'll say plus, and then we will say we have, oh, caps lock, not angry, not, we have, calm Bob. We have found okay, Now we just have this nasty little thing to take care of. Oh, goodness. Okay, so is prime is going to be static. It returns a Boolean. We're going to pass it in a check. Cool. So, for int possible factor equals 2. Okay, so is prime. Now we'll say if check modulo factor equals 0, and curly brackets prime equals false. Okay, so let's clean this up just a little bit. Let's talk through this. Let's try it. Prime hunting. Bum, 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 bum. Okay. Next number. Good. If is prime. Okay. So, let's just make sure that we're getting in here, right? Okay, so checking 2. Oh, you know, it would help. You just need to do that. There we go. Bum, 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 bum. Okay, now that's too much information. I'm going to kill that off just because it's confusing me. Okay, so prime's hunting, not useful. So go away, please. Nope, just one line. Okay, so int range 10. Run it again. Oh, sorry, friends, just a second. Hello. Good. All right, friends, sorry about that. Let's get the share going again. And here we are on screen 4. Good. Okay, so 2 is prime. We found 1 primes. Next number 3. Okay, next number is 2. Next number needs to go away. We'll save this. Okay, 2 is prime, 1 prime. 3 is prime, 2 primes. 5 is prime, 3 primes. 7 is prime, 4 primes. Okay, so I'm gonna open up a Excel spreadsheet. Well, that was a lie. In fact, he would not open up an Excel spreadsheet. I think I've got Excel installed on this machine. I try to avoid pagan tools like this that you have to, oh, you know what? No, I only need one of you. Thank you. Okay, so 10, the answer is 4. So this is our X, this is our Y, and that's not enough to plot anything. So I'll slide this over here. Now, we'll do, ooh, 100. Okay, so 25 primes. 2, 3, 5, 7, 13. Good. 7. I, this is probably going to bite me in the bottom later. But I actually, I have no faith in my ability to memorize primes or to calculate primes. So let's just do this a slightly different way. Okay. Right. There we go. So swing and a miss. There's Eclipse. Can I come back to this? Thank you. Okay. So 97, 89, 83. Hey, I think the code is working. Now, I'll be honest with you, not my favorite way of doing math, but it's going to work it. So now we've got 100 and 25. And now we can change this to 1,000. Save it, run it. Going to run a little bit longer. So 1,000 is going to be 168. And now we're going to do 10,000. I think this is where you get away with that. I'm not sure. Might have bricked it. Hey, it lets me rock. Okay. Two, 9. So now we'll do 100,000. Yeah, see, now it's starting to be like, hey, crazy old man, you and your print statements. You and your print statements got to stop. Comment this out, come down after the for loop, paste it in here. Okay, so 10,000 that time was 9,592 primes. Okay, now this is when we're going to make the old Mr. Processor smoke a little bit. And I might have to walk away, right? But hopefully this little cheat right here, okay, it is running. You can see the little square here is letting it run. And so possibly this is going to work. Possibly it's not. It might just take a little while. But while it's running, let's take a look at the code just a little bit more. So this is basically saying it's a bug for loop, and it says, hey, we're going to check these numbers to see if they're prime. And we're going to check as long as the number is smaller than the range. So notice how it says primes are less than 10, right? And so that's why we're doing the range less than whatever our range is. Now, our number of primes goes up if our number is prime. So how do we find out? Well, we check if the number is prime. I didn't really want to have to figure out how to do that right here. I know kind of how to do it, but it always confuses me and it works with a for loop. So I used this little is prime and just passed it a number, right? So here's where this code is written. So it's going to return a Boolean, true or false, if this number is prime. So is prime starts out being true. We just start out by default saying, yep, it's a winner. Now, for possible factors, we start at 2, right? Because everything has a factor of 1, so that doesn't matter. Possible factor of 2, okay, now 2 is already not less than 2. And I know that's a stupid way to explain that sentence. When this is a 2 and this says less than, and this is a 2, this is false. What that means is on the first pass, which when we're trying to see is 2 prime, it's just going to automatically kick this out and be like 4 skip, boom, return is prime is going to be true because it's just skipping all this crap. Now we'll come back and we'll say 3. Okay, so 2 possible factor less than 3 if is prime. So we'll check is 3, when we take 3 and divide it by 2, how much is remainder? Well, 3 divided by 2 is 0, remainder 2. And so is 2 equal to 0? No. Okay. I'm going to tweak this just a little bit. And I'm going to run that. So essentially, as soon as it finds a number that it's divisible by, then it'll be done. So, by the way, that's a stupid thing to do. The other thing is I'm not actually gathering any time data. So as far as I'm concerned, we can just kind of let this stupid thing run because it doesn't matter. Which, to be fair, for those of you watching the video, I am a super performance nutter. And so giving me a time to find the prime numbers in that range, probably pretty interesting. Now, one last question. Int range Java, is it going to cover 100 million? So this is 1, 2, 3. This is going to be 4, 5, 6. Yeah. So we can just use a flat integer. Now, there is another there's another way to do this. And so I'm going to just bring that up right quick. This is my buddy Peyton Hill. Shout out to my buddy Peyton Hill for always having my back and finding these interesting things in Java. So Java next probable prime. This is for the big integer. And so you can use the big integer and then recast it. Returns the first integer greater than this big integer that is probably prime. The probability that the number returned by this method is composite does not exceed. So it's pretty sure. Okay. I think everything's going to be big integer examples. And so, oh, well, there you got it, my friends. And it did run a little bit faster. High five us for finding a faster way. Oh, there we go. And so that number here is 78,498. Okay, so you've got choices now. You can just like let the stupid thing run, and I will do that. And I'll be through talking for a little while. But in the meantime, let's see if we can Excel. No, not filter and sort. Let's do insert, and then we'll do and there used to be a trend line, and I think you can do linear, exponential, linear forecast, 2-period moving average, more options. So display equation and display the goodness of the fit. So it's not too bad. Linear. Nah, I like that better. I don't like the exponential. Logarithmic? Nope. I think linear is kind of the best fit, and it seems to be kind of a linear relationship. All right, and so right there be your equation. And so, oh, it's still humming. Anyway, this is kind of fun to have, and so this is gonna make a prediction, and so you can say predicted, and this is equals 0.0782 times that cell plus 439, well, or 493, right? 439.42. Okay, so obviously not a great fit. And then you can do error. So this is going to be equals power. Oh, no, not done yet. Hey, oh man, it's been a while. Of, and it's going to be this minus this, and then comma 2. Okay. And we can see that here in the middle, it's getting pretty good. Little big, little big. Anyway, it just kind of shows you where we're getting closer, where we're getting further away. And you can now come in. And now you can come in and do this. And you got this as well. So now you've got a way that you can do predictions and fun stuff like that. This is all basic Microsoft Excel stuff. And even in all that yammering, it still hasn't got the last one done. So I'm going to let this run, but I'm going to come back tomorrow and then I'll run it again. This is just, really 40 or so lines of code, maybe not even all that many lines of code. If you would have had the umph to take this little for loop and drop it into here, maybe you could have even got it into fewer lines of code. Definitely need these extra print statements, but I left them in there anyway. But anyway, friends, hopefully this helps you understand what we're doing here with the finding the primes exercise. So like I said, it's interesting. It took me 20-30 minutes to program it. Hopefully it doesn't take you as long, because you don't take as long to talk about what it is you're doing and stuff like that. But if it takes you longer, that's okay. Try to have some fun with it. There's also grab the current time in milliseconds, and you could also say estimate how long it takes you to find a prime. How long does it take you to run the range? All sorts of questions like that. So have some fun with it and enjoy it. And if you get a chance, hit me up in Discord and show off what you've got for code and how you're getting your code more elegant. You might switch over and try big integers and see if it just runs faster, because if memory serves, that one was actually a stupid fast way of getting the code to run. So anyway, if I get a chance, I'll play with that later. I'm just excited about it now. So anyway, friends, thank you all for your time. Hope you have a wonderful day, and I'll come at you hopefully sometime tomorrow, help you out with a little more of the homework. So thank you, friends. Have a great day. Bye.